So without any further ado, hi, I'm Shawn Drost. It's nice to meet you. I'm an instructor at Hack Reactor. It's a school for software engineers. I'm going to be talking to you today about technical challenges from front-end interviews. So what prompted this talk is a mystery that I've observed. We have a we have a very important process, technical interviews, very easy to hack them, very easy to sort of improve outcomes dramatically. But I don't see a whole lot of that going on. I work with a lot of people that embark on job searches, and their innate approach is to just skip over the whole preparation part, even though A, it's very profitable, and B, it's actually kind of cool and fun. It really just winds up being a process of nerding out about a couple of specific things. So that's what this talk is. We're going to start by looking at a taxonomy of the kinds of interview questions that might come up. We're going to go over some easy wins and look at some technical topics and some non-technical topics. There are going to be a lot of very engaging, interactive activities. We're going to do a little bit of live coding. It's going to be thrilling, and the goal here being to have fun and dramatically increase your performance on a rather important process, and hopefully be the most profitable talk that you're here for in this conference. Because there are not a lot of images that relate to front-end technical interviews, there are some irrelevant baby animals. So, you know, because what's not to like? So this is my job. This getting people jobs, prepping people for interviews is a part of my work. I run the second half of the course at Hack Reactor, and at the end, I'm responsible for getting everyone a job, which is the thrilling process. We have. So I've prepped people for, I don't know, thousands of phone screens and on-sites and whatnot, and they keep telling me the same questions. They report the same experiences. So I'm just here to relay that to you, and I'm here to sort of like bring that experience to you guys, because I would have been sitting in your seat a couple years ago, not knowing most of this stuff. So point being, you guys are not the guinea pigs. The guinea pigs were the first batch of students. By now, I have some interesting observations to bring to you. So, taxonomy, the stuff that we're going to be looking at today, depending on what kind of role you're going out for, you may or may not be looking at being tested on any browser concepts, JavaScript, HTML, CSS, DOM. You may or may not be tested on a whole lot of in-depth algorithms and data structures. You're definitely going to be able to make use of some brief soft skills training. And if you're not looking at roles that involve browser technology, or not looking at roles that involve algorithms and data structures, you're going to be bored for about a third of this talk. So just advance setting of expectations. This guy's adorable. So browser concepts. Let's talk a little bit about browser concepts. It turns out to be a really straightforward conversation because there are only 5 questions that ever come up, actually. They just come up over and over again. If you actually do a thorough job search, I guarantee you will see each of these questions at least twice. This is like a real thing that's going to happen. So let's start off. What is a closure? Why is it useful? And in fact, like, maybe this seems ridiculous to you, and maybe this is a total mystery to you. But I have a theory, which is that most of you guys are in the like, I kind of know this already world, and also most of you would benefit by actually getting on the bike and trying to ride somewhere, so to speak. So I want to do an exercise together. I want you to turn to the person on your that's sitting next to you. Introduce yourself. Say hi. And we're just going to explain to each other what closures are. It's going to be a real quick process. So person A, talk to person B. We're going to swap in a moment. If you don't know what a closure is, it's okay. Just fess up and like talk about your most interesting session. Ready, set, go.
Other than like not vetting looping, yeah, I don't know much else. Yeah, I think it has to do with variables.
Make sure you don't ask any of these questions because everyone knows it by the end of the session. Ask different questions.
All right, either now or in about 10 or 15 seconds, swap over to person B.
Python, PHP, JavaScript.
I'm noticing a quieting volume, so everybody spend about 5 more seconds and try and wrap it up in auctioneer tones if you haven't yet. Okay. Now stop talking to each other. Look straight forward, ignore each other. Thank you. So, the experience I have from working with a lot of people that are in your shoes that have a lot of working experience and understand this stuff, it seems like a ridiculous question maybe even to many of them, is that actually they said about a half dozen times. They realized in the process of explaining it that they didn't have as firm a grasp on something. It takes a different level of understanding to be able to vocalize your experiences than it does to just make use of sort of structures in your brain that are built in some manner. In the process of explaining this stuff, you can also discover problems that you have. So I do this exercise both because I don't like how much people ignore each other at conferences, but also because this is representative of what you should do in the future if you're about to embark on a job search or doing it right now or whatever. Next time you do, actually do this with real humans. Don't just see a question. If you're going through a list of questions and prepping, don't just see a question and be like, yeah, I got that. Just actually talk to another person. Explain things to them. It turns out this makes you way better at life. Also, you reveal things that you don't understand yourself when you're forced to think them through enough to make a complete English sentence. Question 2 that we see every single goddamn time. This is a little bit goofy, so event delegation, bubbling, this pops up a lot, and for those of you in the audience who may or may not be familiar with this, I'm just going to like explain real quick. If we have if you have a series of elements in the DOM, the events that occur propagate outwards in a system called bubbling. So the event registers first on the innermost element that was interacted with, and then propagates outwards. So if you have event listeners on any of the enclosing elements, they will receive those events in that order. That concept's called bubbling. Delegation just means registering an event from a parent node that happened on a child node. If you don't get it, it's okay. It's not requisite knowledge for anything else further. But this is one of the top 5. I want to, true fact, it turns out that the reason bubbling is the way it is, why it goes from the inside to the outside, is because Microsoft won the browser wars. Had Netscape won the browser wars, events would actually propagate the other direction. So there's that fact. I bring up that fact not just to waste your time, but also to let you know that you have a lot of opportunities when describing straightforward technical facts to sort of show that you know much more than what's going on, than the question at hand. This is especially true if it's a dumb question. You can dispense with it quickly. If you have a ready fact that is kind of awesome, you can throw that into the interview. This is a good idea. I took the other 3 out of this talk because I was very short on time, as it turns out. But there is this list. I will be tweeting out the slide notes at the end. And I highly recommend knowing the answers to these questions. They all come up at least once every 2 or 3 interviews. In the unlikely event that you are one day asked a question that is not among these 5 during an interview regarding HTML technologies, it will probably be in this list. This is just a repo of very useful questions. It's the one we refer students to. We sort of like looked through many such lists and figured out this was the one. So that's browser technology, DOM, highly recommended. Learn those 5 facts. Also consider workshopping answers with people, even if you think you know the answers. Oh, look at his eyes. So, algorithms and data structures. Depending on the front-end role that you're going out for, this may or may not be a huge significant portion of the interview. If you're looking for something, unfortunately, it turns out that front-end engineer means one of 2 actually pretty distinct roles. One of them is kind of working on the HTML and CSS, and there's a whole set of challenges involved with that. The other one, it tends to be more rich client, backbone, Angular type of front-end engineer. More software, less design, less very, very different skill set, very different set of questions that you end up with, all called front-end engineer for no reason whatsoever, just because of historical accidents. But if you're going out for the second kind of front-end engineer role, you're probably going to get asked to, whiteboard some code and solve some problems, So with respect to data structures, there's really about 3/4 of questions, honestly, and this is just sad. This is a sad state of interviewing. About 3/4 of data structure-oriented questions, the answer is that there is a sort of like naive solution involving an array and a somewhat less naive solution involving a hash. So it's ridiculous, but this fact regularly, just saying this fact, this is all the information that you need. Students will regularly come back to me now and say like, oh yeah, I saw this question, I was like, what am I supposed to do with this? And then I realized, oh, just a hash. This just happens all the time. So I just want to elevate that in your brains. Consider a hash. If you further conversations about further questions about data structures tend to come up more in interviews that are a little bit out of scope of my talk, and I highly recommend cracking the coding interview for deeper questions. This is something that we have a bunch of copies of this on stock at the school. Highly, highly recommended. Great book. Author is a Google engineer and good communicator. Algorithms. Let's talk about algorithms. There is a pretty similar set of there's a pretty similarly sized set of problems in algorithm-style questions that are addressable really by one generic solution. And the template problem is all anagrams. And we see a lot of different problems that look a lot like this. And what we're going to do is we're going to actually write some code out for this and investigate what that looks like. And we'll talk a little bit more about some analogs that pop up. But I'd say probably half of all algorithm-oriented questions are all anagrams or something comparable. All anagrams is really about combinatorics. It's about you have a bunch of things, in what order can they appear? And once you learn to see that pattern, then it pops up all over the place. So let's write some code. This is gonna be ridiculous. Hands up if you've live coded in front of a crowd. This always goes terribly. Yeah. Are you guys ready? Are you guys ready to roll with this? Okay. So, is this big enough? We're good. Great. So the problem is as follows. We want to call a function all anagrams and pass it a word. And we want it to return an array of all possible anagrams. So that would be like potato, potato. Just kidding. Etc. We could say that the problem was such that only such that the words were real English words. And that would be a rather straightforward problem that we don't need to address separately. After asking you if that was big enough, I'm now going to shrink it. Is it still visible? Yeah. Good. Okay. So one of the things that occurs to me when looking at this problem is that there's a situation in which it's really easy. There's a situation in which the answer is immediately obvious. And if we could only get there, then we would be able to solve this problem on like one line of code. And that there is for situations that are not so the situation that is very easy to resolve for this problem is if the word is 0 or 1 letters long. That would be really ideal. I could write that in a heartbeat. It's that is a hallmark of problems with recursive solutions, and interviewers just love problems with recursive solutions. They do. I don't know. They love them. Like there's kind of a love-hate relationship. We might get to this later. It turns out that recursive solutions are not often optimal. We probably won't get to that. Let's be real. But interviewers do tend to love them just because they are sort of one of those backflips that programmers are occasionally called upon to do that is rather a challenge of your abilities. So I have a really straightforward 3-step process to any recursive solution. Here's what it is. Step 1. Define an empty function with an if and an else in it. Step 1. Step 1, dead simple. In recursive problems, I mentioned that one of the hallmarks is when there's a very easy solution. And in recursive problems, that's called the base case. If you're in a situation where the answer is incredibly obvious, you're in the base case. So step 2 of writing a recursive solution is to fill in the if statement to solve for the base case. So if word length is greater than, less than 2, then you just return word. Right? That makes sense. If we call all anagrams of P now, it should actually work. Are you guys ready for this? Let's actually run the code. So this should return just an array like that, right? By the grace of God. I cannot claim credit for that. So step one of writing any recursive problem is write a function with an empty if else in it. Step two was fill in the if statement, solve for the base case, the situation in which the answer is just no duh easy, just incredibly too easy, even almost to type out. And step three is also easy, but it involves a leap of faith. Step three is fill in the else case with what I'm going to call the step case. So what you want to do is you want to write some code that will solve the problem by calling the same function, passing it something that's a step closer to the base case. So we want to call anagram, we want to solve the problem by calling all anagrams, passing it a shorter word. A shorter word because if the word gets shorter, then you're stepping towards the base case. So how do we solve the problem by shortening the word? So let's, I'm going to pseudocode it out first in comments. I'm going to say like, pull for each letter of the word in turn, pull that letter out of the word. So this will leave us with a shorter word. Step three. We want to call all anagrams on shorter word. This is going to give us an array. So we're going to get an array of anagrams from the shorter word. This is calling all anagrams, stepping closer to the base case. And this gives us all of that. We're just going to have blind faith that this step works. Just out of nowhere. If necessary, we can talk about where that blind faith comes from after. But until we're done with step three, I'm just going to ask you to trust blindly that if you write this base case correctly and you solve this step case correctly, assuming this function call works, then this function call will work. So we have this short word array. Last step, add letter to short word array, to each word in short word array. So this is all stuff that's going to run once for each letter of the word. This is going to give us all of the anagrams that start with letter. And when we're done getting all of those arrays, then we'll have to join them somehow. Okay, I'm going to implement from the pseudocode. So we have 4. Now, as I'm typing, I'm thinking, there's so much about this that I want to do differently, and I want to fix, and I want to optimize. And in an interview situation, I would pause to vocalize that, maybe, to the interviewer and say, like, I really want to optimize this as I'm typing it, but I'm consciously holding back because I want to end up with a solution that works before I start twiddling with it. I mention this both because should you be in this situation, I want you to avoid twiddling with a perhaps working solution until it's done and working. And B, because I think it's also a good idea to communicate that. So letter equals I. Feel like this is done. That's gonna, whoops, no. There we go. I'm too terrified to actually try to go on without testing this. So I'm console logging each letter of the word in turn. I'm hoping this is gonna print out all of the, look at that. Potato. Okay, pull that letter out of the word. I always forget whether slice or splice pulls things out of the middle of words. I always have to look that up. I'm going to pretend that it's. I want to let you know that it's okay to say stuff like this during interviews. This is fine. It's okay. Those are very similar. It was a dumb idea to name those functions so similarly. You can say that. I always forget this. Do you know which one's which? Slice. Cool. So let's say oh wait, this is a. Is that how slice works? You want to slice out one letter from the starting at the ith index?
No, you want splice for that.
And in fact, I think that splice does not return modified word. It modifies word in place. Let me explain what I mean. Sorry, what?
Because the word is not an array.
Oh, right. I love live coding, guys. It is the best thing in the world. Index, how many?
An empty string in there. That's an empty string. That's split it, yeah.
It has to what?
That's an empty string.
Oh, right. All right, substring is going to be easier. You're right, anonymous person over there. Eesh. potato. So now try. Yeah. Yeah. Good. Is that going to work? No way to tell for sure. No. Right. I could explain why that happened, but would take a long time and be boring. This is not going to be convenient to convenient step to test. So what I'm going to do initially is just return. Eesh, that's not going to be convenient to test either. So going to loop through and add. Going to loop through short word array and add letter to each of those words. Okay. So we're going to create an array of all the answers. We're just going to return we're just going to return better idea. Let's just push on to all answers. Are you ready? No. I'm not ready. I'm going to go anyway. This is impossible. This could never possibly work. Well, I don't deserve that. But it happened. Okay. So we have here all anagrams. So many things I want to do this. Looking at this code, I hate it. I want to change everything about it. But it worked. That's great. It's fantastic. I want to repeat the 3 steps because they're valuable, and then we'll go on to talk about all anagrams a little bit. So step 1, write out a function with an empty if-else. The if is going to represent the base case. The else is going to represent the step case. Step 2, solve for the base case. The base case is when the answer is incredibly dumb. Step 3, and step 3 can end up being rather lengthy, is to solve for the step case by or by calling the same function, stepping closer towards the base case with the arguments. So there was actually a technique I could have used in this process that would have made me look way better, actually. And what I could have done in the process when I was stumbling with some section is I could have said, like, well, you know what? This is complicated, but I'm confident I could figure it out, especially if I took some time to Google. I could just say, like, remove letter. Now, I could later implement this, but this is sufficient to communicate what I hope to communicate to the person who's evaluating me, in this case, you guys. Now, I mean, the code isn't going to run, but you're usually whiteboarding this anyway. And what it allows you to do is skip past any stumbling blocks that you run into in the process. Highly recommend that. Another even dumber technique that is 90% as effective is just to put some question marks here and explain verbally what it is and say, I'll come back and fill this in later. You don't even have to figure out what to name your helper function. This totally works. This is way better than stopping and getting stuck on one line of code that's supposed to do some simple thing. Remember how much you judged me in that moment? You don't want to be judged like that. Okay. All anagrams seriously comes up every day of the week. Please stop following me on Twitter. You're making my phone buzz. It's really distracting. All anagrams. Hopefully, I've included some of the other names under which all anagrams appears. Oh, I did. Yes, that's great. You might have heard of the N Queens problem. This is about the same thing. Or like how many different ways are there to break a dollar given that you have a coin of like 17 cents and 3 cents and 8 cents? Equivalent problem as well. I mentioned that this is a combinatorics. This whole class of problems is basically combinatorics. If you know what combinatorics means, it's great. If you don't worry about it. It doesn't matter. So this problem appears all the time. If you feel confident in solving all anagrams, you will run into slight variations on it and feel great about yourself. Highly recommended. Yeah. Okay.
Sorry, what is the recommendation? Just practice those kind of problems.
Practice all anagrams specifically. Because it can be as specific as that, because I mean, it's important to practice the broader class of problems. In the slides, I hope to cover easy wins. All anagrams is the easy win here. If you just know that one thing, then your life will get better. If you want to put more effort in, cracking the coding interview is the right place to go. So soft skills. I would be doing a disservice here if I did anything other than pop open this page and tell you how important it was. This is such a crucial website. I was going to write something better than this for students, but I tried and I couldn't. This is just phenomenal. We're actually going to open this up. This is how important this is. We're actually going to open this up and look at it together. Every single heading blows my mind. I love this. So early on, you see a lot of like back and forth, blah, blah, blah with the interviewer. What's going on is that they're trying to assess, like, how do you think about code? They're trying to assess, like, how do you work as a team member? They're trying to work. Can they depend on you? If you say you're going to do something, can you do it? If you're on a team and something bad is about to happen, can you stop it from happening? Please read this whole document on your own time. We can't do it together, unfortunately. Communicate. Every single interview you go to, you will under-communicate on. I promise you. Say more things. Think out loud a little bit more. Slow down. Get unstuck. I talked a little bit about a couple of specific techniques of doing that. For doing that, ask for help. Do it the dumb way. Highly recommended. Wait for a hint, even ask for a hint. That's a great idea. Wow, I could have sworn this was in here, but stub out either with question marks or a call to a non-existent helper function, that some part of the code that you got stuck on for a moment, so that you can go on to dash out your thoughts about the rest of the code. And it goes on like this. Of crucial value, we're running low on time, and I want to leave a little bit of time for Q&A and for you guys to get to the next session. Cannot emphasize how important this document is. This will just completely change your outcomes. It's in the presentation. I'm tweeting the presentation momentarily. And that's it. This is all from me. Thanks a lot for being here and encouraging me in your hearts through the live coding. Anyone have any questions? One in the back.
So if you're on the other side, if you're an interviewer, how do you actually find out if someone is fit to do the job? And it's not just trying to crack the interview.
So how do you interview? It's a crapshoot. There's no good way to do it. This is a widely acknowledged truth among everybody that has ever interviewed a developer. I remember going into my first interview. Nobody told me how to do it. There's no science about this. You just go and you're probably going to Google a list of questions at some point in your career. If you haven't interviewed somebody yet, you'll probably end up Googling a list of questions or asking your coworkers what they ask. This is cutting edge science. That's how they do it in the real world. That is as best as the software engineering industry has ever done.
Should be just pair programming.
I think that there are other approaches. Pair programming is one of them. Small contract jobs is another, that make an effort at approaching the problem differently. My personal opinion is that they're both valuable. They both show useful. They both give you useful data, but they both have flaws that are equally large.
Along those lines, I've heard actually, how useful do you think it is to have somebody bring in like some examples of their code and walk you through it, or at least walk you through their overall structure and explain the reasoning, or is that overkill or underkill?
I've tried that in the past with people that have GitHub portfolios, and there's a couple problems with it. One of them is that you don't have a standard template to go from. So when you're interviewing people and trying to assess them, one of the things that happens is that mostly you just say how much you like them, and you will decide very early on whether or not they are good, generically good, and then you'll sort of fit everything else into that mold. And in as much as anyone has a plan for interviewing, it is try not to let that happen. So while in theory it would give you more information to go through the code they've written in some non-toy context and talk to them about it, and while that does have things to recommend it, it lacks that one important criterion of, do I have a baseline such that I can objectively compare two different people? Have I seen someone else do the same thing this person is doing, such that I have more than just what my gut says about this person? Because I don't trust my gut. It's made out of intestines. This guy.
Can you think of any benefit to doing coding on paper or on whiteboard as opposed to on a computer?
No. Nonetheless, such is life.
The advantage for it, they can't make you run it.
All right. Well, unfortunately, I had better send you on your way. Thanks so much for your time. It's been a pleasure. I'm at Shawn Drost. I will be tweeting this in a moment.